Hello students, good morning. Till now we have studied the force between the charges and what is electric field and what is electric field intensity. And at the last turn we discussed about electric field intensity due to point charge. And the next that we have to discuss is the electric field intensity due to the line charges. And next we will discuss the electric field intensity due to the surface charges. And the last one we will discuss about volume charge. So one by one we will discuss all of them. So due to point charge, the electric field intensity we have already discussed. Now we will discuss about the field intensity due to the line charge. So let us start the field intensity due to the line charge. And at the last turn, we have seen that electric field intensity can be written as 1 by 4 pi epsilon. Hope everyone remember this. The charge divided by distance between the charge and at the point of interest, that is the r square in the direction of AR. This is the vector quantity, so it will have a proper direction, that is in the direction of radial vector. Now we will try to find the electric field due to the line charge. So let us first try to find what is line charge. Line charge we can understand the charge is uniformly distributed along the line. Okay, for example, point A, point B, the charge is distributed from point A to point B uniformly, and we can consider the line charge density is rho L. Okay, this is the line charge. Now if we wish to find the electric field, then the first thing that is very clear, should be very clear, we have to find the charge. So in this case, if we wish to find the total charge, then what we should do, we should assume a differential part of it, that is differential length, and if we will multiply the charge density with differential length, then it will give the charge occupied by this dl length. So what we can do, dq can be written as rho L dl, as our aim is to find the total charge. So to find the total charge, we have to integrate it from point 1 to point 2, that is A to B. It will give us total charge. Okay, so in this way one term came to know. The second concern is R. Now let us try to derive the relation to find electric field intensity in this case. So for derivation, assume the line charge is distributed along the z axis. For simplicity, okay, from A to B, and these are the coordinates, okay, anti-clockwise. It will give you positive direction z. Okay, now we have to find the intensity of this line charge at any particular point, for example at point P, okay, which coordinate is x, y and z. In this case, the first thing is q should be known and the distance between the point of interest and the charge should be known, but here the length is not fixed, though we can find the full q, but the distance between this to this is varying. So let us derive in this case. And similarly to this, assume a particular section, that is dl, okay. Consider, extrapolate this and try to draw perpendicular from this point to this line, that is on the extrapolation of the AB. Okay. Now for this region we can consider it is Q, or we can say the charge is dq, and we know the distance is r, but r is varying, so we cannot generalize it for full length of the line. So dl, this coordinate, this point's coordinate will be at z axis, x will be 0, y will be 0 and z will be there. Okay. Now this is the point, considered point, and assume the coordinates of this point is 0, this is z axis, so remaining coordinates will be 0, 0, 0. Already we have assumed z here, so we can say it is z dash. Okay. So since it is z dash, the final position is z, z dash. So differential length in this case will be a small change in z, we can say dz dash. Okay. Now this is the construction of the figure after extrapolation of the AB to make our derivation simpler. Consider this angle that is made from the perpendicular to the line, it is alpha. Now if we have this condition and we wish to find the electric field intensity, then according to this we can write rho L, the density of the charge distribution is rho L, similar to this, rho L dl, okay, we can say 4 pi epsilon r square. For this charge only we are trying to find the electric field intensity, that is we can say dE. Okay. If we are integrating, then there is no need to write dE, r square in the direction of AR. AR is this AR direction. Okay. And dl is nothing, just dz, we can say rho L dz 4 pi epsilon r square AR. And what we can write here? If this length is considered as rho, this is rho L, charge density, line charge density, then don't mix up rho L and rho. This is the perpendicular distance from point P to the extrapolated line. So from here, what we can do, we can write rho L dz dash vector r divided by 4 pi epsilon r cube. This can be written as, what is r by the way? R is, suppose we wish to move from here to here, then according to the definition of differential length as we have studied in the case, in the beginning of the coordinate system, we will move from here to here and then here to here. So r can be written as, just if we wish to find the r, then what we can say, this is the final minus initial, z minus z dash, remainings are 0, so don't worry about that, plus this is what? Rho in the direction of, if we will extrapolate, then it will be a rho. We can write like that, and if we will find the mod of this, then it will be z minus z dash square plus rho square power 1 by 2, and if we wish to find the power 3, then it will be 3 by 2. Okay. So if we have to find E, electric field intensity, in that case we can say rho L dz dash, and r can be written as, from here r can be written as z minus z dash az plus rho a rho divided by 4 pi epsilon r cube. R cube means just this cube, z minus z dash square plus rho square cube. Okay, this can be written like that. See, we don't know z, we don't know, we can say we don't know z and z dash, both of them we don't know, because the known term is a and b only. So what we can do, we can write z minus z dash in terms of the known term. Known term can be, see here, what known term can be? Known term can be, if you are making this like that, and you are giving the name of this angle alpha 1, alpha 2, then the known term are alpha 1 and alpha 2, that is related to A and related to B. Okay. So all the terms, rho L is known, this is known, and I think rho is known. The remaining terms z and z dash should be put in the terms of alpha 1 and alpha 2. So from here, z minus z dash z dash can be, if this is alpha, then in this triangle we can say perpendicular divided by base is equal to tan alpha, we can write in this triangle. So from here we can say z minus z dash is equal to rho tan alpha. If we apply the limit from alpha 1 to alpha 2 in this case, then we can find, okay, hold on for applying the limit. Z minus z dash can be written as rho tan alpha. Okay, so from here if we differentiate, then we find minus dz is varying from here to here, so we can say minus dz dash is, this is fixed. Okay, so the differentiation of this will be 0, this is varying, it will be rho tan alpha differentiation will give you sec square alpha d alpha. Now from here two terms are known to us now. The first one is z minus z dash is equal to rho tan alpha. Second is minus dz dash is equal to rho sec square alpha d alpha. So we will put z minus z dash and dz dash in terms of rho and alpha. So put it here in this one. So it will give us electric field intensity will be the fixed value rho L, dz will be multiplied with minus from both the sides, minus rho sec square alpha d alpha, okay, dz, and z minus z dash you can put rho tan alpha az plus rho a rho divided by 4 pi epsilon z minus z dash rho tan alpha square plus rho square 3 by 2. Further, rho from here and rho can be taken out. It will be rho square. Here it will be rho power 3, because once it will be outside from this bracket, it will be rho power 3. So the including all electric field intensity will be, take minus out from all of them. Sec square will be considered out from here, 1 sec will be left. So rho L 4 pi epsilon, since the combining of these two, 1 plus tan square alpha, it will give you sec square alpha, it will give sec to the power 3, sec square is already there. Once it will be cancelled out power 2, 1 power is left of sec, it will go up, it will be cos. So cos and tan, it will be sin alpha in the direction of z, okay, plus cos alpha a rho, here is d alpha, and rho is, one rho is left, rho common, rho square, rho power 3, 2 is cancelled, 1 is left. So this is the final term after simplification of this. Now we will further simplify, minus rho L 4 pi epsilon, this rho is there, sin alpha, now the variable is alpha, that vary from alpha 1 to alpha 2. So it will vary from alpha 1 to alpha 2. So sin alpha will give you minus cos alpha from alpha 1 to alpha 2 in the direction of Az, plus cos alpha integration will give you sin alpha from alpha 1 to alpha 2 in the direction of A rho. Okay. So minus rho L by 4 pi epsilon rho, it will be minus cos alpha 2 minus plus cos alpha 1 in the direction of Az, plus sin alpha 2 minus sin alpha 1 in the direction of A rho. This is the final statement regarding the electric field intensity due to this line charge that vary from alpha 1 to alpha 2, where alpha 1 and alpha 2 are the angles made by the perpendicular to the ends of the line charge. So this is the final statement regarding the electric field intensity for line charge AB.